application, transformers. Transformers can take alternating voltage and step it up to a higher voltage, or vice versa, it can take high voltage and step it down. It does need to be alternating though, because of the whole induced EMF depending upon a change in flux. Simplified version of a transformer. Have some sort of iron core. Your source comes and wraps around this core some n number of times. This has to be an alternating source for the transformer to continually work, because the flux needs to continually change in order to induce a voltage. So this is the source, which is also called the primary coil. With an alternating power source, the current through this coil is going to be alternating with time. It'll flow one way and then the other. It will alternate back and forth. So it's creating a magnetic field that is changing with time. And it is actually inducing a voltage in itself. Its own current is changing in direction. Its own magnetic field is changing with time, which means it's inducing a voltage in itself. We actually call that self-induction. The voltage that it's inducing, we'll call it E1 for the primary, is equal to negative N1 d phi dt. It depends upon how fast that flux is changing. Now, in the transformer, we have a secondary coil as well, which is what is on the other side of the transformer being powered. The secondary coil wraps around this same core. It does not generally wrap around the same number of times. That's supposed to represent the resistance in your circuitry. This is called the secondary coil. It, as well, because it's wrapped around the same core and the primary coil is changing, the magnetic field is changing continually, its flux is also changing continually. So it has an induced voltage. I'm going to call it E2 for the secondary. And its induced voltage depends upon the number of turns it has and the rate at which the flux is changing. But the flux is changing at the same rate for both coils. They're surrounding the same core. They're surrounding the same area there. So d phi dt is the same for both the primary and the secondary. The rate at which the flux is changing is the same. So that means we can set the ratio of the induced voltage in coil 1 over N1, which is solving for d phi dt. We can set that equal to the voltage of the second one, secondary, over N2. We sometimes rewrite this and say voltage 1 over voltage 2 equals N1 over N2. So the voltage, the ratio between the two voltages is entirely dependent on the number of turns. With the way I've drawn it, I've drawn our source one is 1, 2, 3, 4, 5 turns. And my secondary is 3 turns. So that means voltage in the primary is 5/3 times the voltage in the secondary. It depends upon what you want your transformer to do. There are both step up and step down transformers. This one is a step down transformer because voltage in the primary is higher than the voltage in the secondary. Step down transformers are what you have outside of all your households. The power company, when they are sending power to you, they send it at a very, very high voltage so that the current will be very, very low. That minimizes, or at least decreases, the amount of energy that's lost as the electricity moves through the wires. power lines have some sort of resistance. If they have current flowing through them, they're going to dissipate energy. It would be a huge waste if all of the energy the power company was sending to us was gone by the time it got to our house. So the power company sends us our power at really, really high voltages and very, very low current. Remember, power, one way to write power is current times voltage. They're sending us a set amount of power, high voltage, low current, but as far as our household goes, we don't want a high voltage, we want a low voltage. In the process, as our voltage goes down, the current flowing through our circuitry goes up. So we have transformers, these are called step-down transformers, where we step the voltage down to a value that we need. Your laptops, part of your little AC-DC converter is a transformer. It takes the wall outlet at average of 120 volts and steps it down to a voltage. It is also an AC to DC converter as well.
So current is they're inverse of each other. Power remains the same.
Power remains the same, ideally. Now, granted, there's always a little bit lost, but as voltage goes down, current will go up. Exactly right. If N2 is bigger than N1, so if your secondary coil has more turns than your primary does, that would be considered a step-up transformer. It will take a low voltage and step it up to a higher one. And that's what they would use at the power companies, to take their voltage and step it up to the high voltage they're going to transmit with.
Is there a limit to how that ratio?
A limit to this ratio?
Yeah.
Not that I know of. Other than the practicality of creating a certain number of turns.
You have a maximum power transfer as well.
Yeah.
With that. So if you're inputting 10 amps a foot way, you'll step that down, won't step up.
Right.